All right. Just so you know that this is not will not be a treatise on the Star Wars universe and the lack of canteens on the Death Star. I just want to show you that as we started off. Now I've made one crucial mistake standing up here right now. I have started to eat candy, and it's candy that's going to apparently last for 3 hours because I can't get rid of it. So I apologize in advance if I choke on it or something. So, good day, gentlemen. Thank you for coming to this session, which will be about massive migrations of our machines into Azure. How many of you in the audience are using Azure infrastructure services today? Ah, not many. That's too few. I have to do something about that. Okay. So that will be the topic, right? How to migrate virtual machines into Azure. I'll be covering a lot of different ways to do that, but first let me just introduce myself. My name is Morgan Simonsen. I work at a company called Lumagate. We specialize in cloud computing, any cloud, public, private, government cloud, whichever you prefer. And we're really about enabling businesses to adopt the cloud model of service delivery. So we do consulting on those things, and of course we have a focus on Microsoft. If you have any questions, please feel free to ask them during the session. If not, I'll try to be here a little while afterwards. I have a plane to catch, but I'll try to be here. If not, you will get a copy of the slides, and my contact information is in there, so call me anytime and see if I can help you out. All right, the guy to the right of me in the picture there is Scott Guthrie, who is the Vice President of Microsoft Azure. I met him in the Microsoft headquarters a year ago. Very interesting to have a chat with him. I guess you all know as well as I do that Azure is one of the main things that Microsoft is focusing on in the future. Office 365 and their software as a services offering. All right, so let's get started. I'll start off with giving you an overview of Azure IaaS services, just so we're on the same page here, and also let you know if you're in the right session or not. Then I'll talk generally about how we can get our machines into Azure and reap all the benefits of Azure IaaS. And I'll give you an introduction to the main topic of the talk, which is the Migration Accelerator, the new tool that Microsoft has given us to make this even easier. I'll have a look at the component setup and what they call protection of this product, how we actually prepare our servers to be migrated. And we'll also, of course, do the migration and talk a little bit about troubleshooting. Now, this product is in preview, just so you know that. So, as I always do in my sessions, I do this in the context of a fictional company, which is presented on this slide, which we created to have sort of like a master demo environment to show off all the stuff we're doing. So instead of just using Contoso or demo.net, we tried to come up with a scenario that we can actually use for different things. So this is the reference you will see throughout the demos I'll be showing you. This is the demo environment that we're running. So this company, we have on-premises servers, that's the bottom square. We have regular IaaS services running in virtual networks in the Amsterdam data center, and we have also remote app IaaS services deployed in the same data center. So this is just to get you an idea of the basic setup. So what we're going to do here is we're going to migrate one or more servers from our on-premises network into Azure with as little downtime as possible and have them running up there just as they were at home, with, of course, no loss of data and hopefully only a very small interruption in service to the users, which we can easily do, you know, on an evening or on a weekend or whatever. So let's first start up by me telling you a little bit about what Azure actually is. Now, the pillars on the left, right? That's where we all are today, or at least have been. We are responsible 100% for every service we run, right? From how the server room is going to look, to which air conditioning unit we're going to have in there, to the IT policy at the top. Everything is our responsibility. Traditionally, in that model, we spend somewhere between 60 and 80% on the lower 4 blocks. So storage, networking, servers, virtualization, we spend an disproportionate amount of our time and money just maintaining that layer. Now, the first thing we can do to optimize that is that we can hand over responsibility for those 4 things to a service provider. In this case, we're talking about Microsoft Azure. There are many others. Amazon Web Services, Rackspace, a lot of vendors in this space. Microsoft has some unique properties that I'll come back on, but that's really what we're doing here. So we don't care about storage or network or any of that anymore. We just care about the actual VM container running in Azure. This is the scenario we're going to migrate into today. Now, the next one, if we really want to get, cut down on cost, is we say we don't want to care about the operating system or the platform or the runtime. We only care about 2 things, code and data. If you're building the next Facebook or web app or whatever, this is where you want to be. You want to sit in your DevOps tool, Visual Studio or something like that, and just deploy your code directly into the platform as a service offering. You don't care about storage or Hyper-V or antivirus or anything of that. You just care about your code and data. So that's really where we're trying to get, right? You don't want to spend time on all that other stuff. So IaaS is really an intermediary temporary step, right? IaaS is going to go away. We'll have IaaS for some years, of course, but it's really just an intermediary step to get over to platform as a service, or maybe even better, which is the one to the far right, software as a service. Software as a service is like Gmail or Office 365, right? Where you don't even care about code and data. You just say, I want email. I want collaboration. I don't care how. So Azure is offering services in the 2 in the middle, right? Where the circle is. That's where Azure is offering its stuff. So in Azure IaaS, Microsoft has decided to support every major vendor of operating systems today, not just Windows. They offer Linux, SUSE, CentOS, Ubuntu support as well. And actually, a funny story, the founder of Ubuntu has, given Microsoft a lot of credit for what they've done in making it easy to run Linux on Azure. I don't have time to tell you the full story, but look it up. It's really funny. So the main patterns we're seeing with Azure today is, first of all, test and develop, right? We want agile testing environments. We can provision 25 machine testing environment in Azure in half an hour, right? That kind of agility. And everything in Azure is built by the minute, so we can run that environment for 3 hours and then just throw it away later. And we only pay for those 3 hours. There is no investment or upfront cost for us at all. We can do what we're going to do today. We can lift and shift our production apps, saying, hey, it's time for me to either upgrade my own data center and pay a couple of million in new hardware and SANs, or I can just migrate everything over to Azure and move everything from capital expense to operational expense instead. We can use it for extension. We can create a network hybrid between our network and Azure and deploy new services into Azure. We have a lot of customers doing this. We have SharePoint projects, things like that. They need a bunch of servers. We don't have room in our existing environment. Just put them in Azure very easily. And of course, Azure is running on cloud scale. We have now 19 sub-regions throughout the world, where one region typically has a couple of million physical servers. The smallest data center in Amsterdam has 400,000 physical servers, running on average 4 to 5 virtual machines. So it's a huge scale. Now, in this IaaS structure, we can run, we don't have the same flexibility that we have at home, right? I can say, I want 3 cores, 2.5 gigabytes of memory. We have virtual machine sizes that we have to pick and choose from. And you may think that that's a limitation, but it's really not, because the selection is so diverse that it really doesn't impact us. And it's very, very cheap as well. So the first generation of VMs that we could create in Azure were called the A series, or the A family. And those are the most used machines today. They offer basic performance, a lot of cool features like both internal and external load balancing, availability sets, things like that. They come in regular memory and high memory SKUs. Recently, they launched something called the D series, which have more powerful CPUs, more memory, and local SSD drives, right? And just this January, they launched something called the Godzilla family, right? Where I think the largest VM has something like 450 gigabytes of memory and 6 terabytes of local SSD storage. So there really is no, I don't think anyone needs machines bigger than that. And if so, you can create 2 of them, right? Obviously, these machines cost a few bucks each month, but we can really scale to the latest and greatest requirements for application processing. We're also offering back-end premium storage, which is all SSD storage for all your VM disks, right? So we don't have to rely on regular spinning disks anymore either. So it's really not a performance problem anymore in the cloud. Now, the basic setup of migrating into Azure is you have to make your machine virtualized, right? Now, most of us, all of us are probably running virtualization today, either Hyper-V or VMware or something else. Azure is based on Hyper-V, so we need to convert our disks in some way into a format that Azure can understand. And that disk format is the VHD format that Microsoft has made free for all to use without any cost at all. And once you've managed to do that in some way, there are several different ways to do that. You can upload this disk into Azure Blob Storage, which is this storage solution that's backing all the VMs running up there. And from that, we provision a VM and run it just like we used to at home, right? There is no difference. This is the same server. The only thing that's changed is maybe the number of CPUs and the memory you had and the IP address. Apart from that, have exactly the same server, and you are in absolute control of it, just like you were at home. Microsoft, unless you want them to, have no insight into your virtual machine. You can run whatever you want in there. Obviously, if you do things like use it as a botnet master clone or something like that, they're going to notice and probably shut you down. But apart from that, it's your machine. You can do whatever you like. Now, the good news is that should you decide that, hey, this wasn't for me, there is absolutely no lock-in in Azure. At any point in time, you can say, I want to extract all my machines back into on-premises data centers or a competitor data center or whatever. So it's really portable. There's no need. We don't have to fear that they're going to lock us in. We don't change the disks in any special Azure way that makes them incompatible with what you're running on-premise. So this is a really good news. So how do you get your machine into Azure? There are several options, and I'll run through them really quickly. The first one is that, hey, you can do a manual copy. I want to copy, I have a couple of VHDs here. I copy those into Azure, and I create some machines, right? This is obviously an offline copy. That machine can't be running while you're doing the copy. And it's also manually administered by you, which is not very cool. But this works for maybe 1 or 2 machines. You can do the same thing with PowerShell, still an offline copy, but you can do it fairly automated, right? Azure PowerShell module is very good, a lot of cool features, great for automation. You can orchestrate a lot of stuff, but still a manual offline process. You can use a GUI tool called the Microsoft Virtual Machine Accelerator. One of the main features of this tool is that it can directly talk to VMware and migrate your machine from VMware directly into Azure. Still offline, still automatable by PowerShell, but it has that feature. It'll also prep your machine and get rid of the VMware tools and stuff like that, all without destroying the original VM running on VMware. So it's a great tool to test things like that. But still, large machines is going to take a lot of time to copy into Azure, right? And they have to be offline. The disks have to be in an offline consistent state when you copy them. Otherwise, you will have corruption when you start them up on the other side. So, and even though you might have the greatest internet connection in the world, large servers will take time to copy. And you will be subject to some form of throttling in Azure, right? I have never actually met the top. No matter how good an internet connection I had, I always was able to max that out copying into Azure, but there will be a limit at some point where you will be throttled. And that makes it hard to do large-scale migrations. So the solution to this is to have some form of online copying, right? Online synchronization of the machines between your data center and Azure. One option for this is to use something called the Azure Recovery Services, which are really meant as a disaster recovery tool, where you can say, this group of servers I want to protect. I want a second site established in Azure, identical to the one I'm running here, and if my data center explodes back here in Norway, I can just fire up the exact same environment up there. That's what ASR is really meant to do. But it can also be used as a migration solution where you say, hey, it's Friday evening, I'm going to shut off my server room, I'm going to start everything in Azure, and you have your complete environment replicated and synced and running in Azure. So that's sort of like a secondary use for ASR. But what we're going to be talking about today is the Migration Accelerator, which is specially purpose-built to do migrations, right? That's what it's designed to do online synced migrations of hundreds of VMs, if you like, into your Azure subscription. Now, MMA or MA has different features as well. It can, for instance, synchronize two separate on-premise VMware environments with each other using the orchestration in another part of Azure Site Recovery. But we're going to discuss the migration aspects of it today, right? So that's our tool. That's our topic. Now, there are some things to be aware of with regards to what Azure can support and what you might be running at home. The first thing and the one that gets the most attention is that Azure does not support the second generation VHDX disk format. So if you are in the unhappy position that you're running all your VMs on VHDX, you cannot copy them directly into Azure, right? But with MA, that's not a problem because Microsoft Migration Accelerator does in-VM copy. It copies blocks from within the VM container into another one, so it doesn't actually see the drive. But if you want to copy VHDX files, you have to convert them first. So, and you can also only do thick provisioning. You cannot resize a disk once it's in Azure. So just make sure you know that. That's why we always create the largest data disks we can. But the good news is that Microsoft is only going to charge you for what you actually consume within a disk. So we always provision 1 terabyte data drives in Azure. But if you use just 100 megs, you pay for just 100 megs, right? It's thin charging. The maximum operating system disk size is 127 gigabytes. That's probably going to impact some of you. You have to change that before you try to migrate it into Azure. And this is true for any sort of migration you choose. Data disk size, like I said, 1 terabyte, cannot resize. And this is a really funny one. The disk size must be an exact multiple of 1 kilobyte. 1024 bytes. I discovered this once when I did a manual copy of a disk into Azure, a very large disk that took a very long time. Monday morning, I tried to provision a VM. It says, no, I cannot do that because you are not an exact multiple of 1024. Good news is that the migration tools, they take care of this for you. They handle that. All right. Next thing to be aware of is that Azure only supports x64 operating systems. You can run 32-bit. I have a couple of blog posts on how to run Windows 2000 in Azure. Great for nostalgia, but completely unsupported in every way. We also have no support for Gen 2 VMs. So the second generation Hyper-V 2012 virtual machines cannot boot unmodified in Azure. And that's because they're using Secure Boot and UEFI firmware. And they also might be booting from a SCSI disk, which is not supported. So we're only going to support the first generation. And there is also no support for clustering or NLB. We have replacement technologies in Azure to handle that, but that is not directly supported. If you want to know at any given time what actually is supported in Azure and not, you can have a look at that knowledge base article right down there, which is an updated list of everything that is supported and not. And if not, in what way in Azure. And like I said, you'll get the presentation. Now, so the solution to many of our migration needs is this tool, the Migration Accelerator, which we'll spend the rest of the session talking about. It's in preview, meaning it's a beta, but it sounds a lot less scary if you call it preview and write the word with green text. So that means that it has no SLA, right? There is no SLA on the service, but it also means that it's free, so you don't have to pay anything for it. Migration Accelerator is the result of a purchase Microsoft did of a company called InMage, which specialized in virtual machine replication and migration. So they bought that tool and now working to integrate it into the service offering in Azure. So we can migrate from pretty much anything: VMware, physical server, Amazon Web Services, on-premise Hyper-V. You can use that to migrate into Azure. One thing to note about MA is that it only supports migration into Azure, not out of Azure. At least not now. So that means if we want to get out again, we have to copy the disks in another way. One of the really cool features is that it is able to understand a set or group of machines that together is offering a service. Let's say Exchange, right? Exchange is dependent on Active Directory. MA will figure that out and group those servers together so that you can migrate them all at once, right? So you don't have to necessarily figure out the inter-server dependencies in your applications yourself. It has intelligence to discover that. And when you migrate to Azure and you start them up there, it asks you, hey, in which order would you like me to start these, right? So the offering here is that since we're synchronizing machines and not taking them down to copy, we should be able to fail over in a matter of minutes, right? This, of course, depends on the amount of data you have and how many VMs you're moving at once. But once all your VMs are synchronized in the cloud, I'll show you exactly how to do that, not what it looks like later. You should be able to fail over in maybe just a couple of minutes. One server takes 10 minutes. 50 obviously takes a lot more. But it's not a prohibitive amount of time, like it used to be with manual copy. If you want to try this, you can sign up on the MA page. Like I said, it's free. It'll tell you that it's only available in North America. That's not strictly true, but the orchestration part of it, the service that is actually orchestrating all the other moving parts, and there are quite a few moving parts in MA, is handled only from United States data centers right now. That really doesn't matter to us because the resources we are migrating, they're somewhere else. They can be here, they can be in North America, and the data transfer happens between those components and not the orchestrating part. It only sends signals to the other ones to tell them what to do. So that you shouldn't be scared by that. And there is no need to wait to try MA now. I have used MA from North America for several migration projects here in Norway. Works fine. No problem whatsoever. The data never enters the orchestration portal. It's directly copied between your on-premises services and your other services in Azure. You don't see that. So, like I said, the product is free, so you only pay for the Azure services you actually deploy. If you migrate 50 machines, you are going to start obviously paying for 50 machines, but the migration itself doesn't cost anything. So it'll take a couple of days before you're activated once you sign up. But if you plan ahead, that's fine. And you can also use the orchestration page for several migrations. And I'll show you my portal afterwards so you can see how we're using it for more than one scenario. Now, this is how this is built up. And there are a lot of moving parts in Migration Accelerator. A lot of components, a lot of dependencies, a lot of communication paths. So it can take a little time to set up correctly and test, right? So just be aware of that. There are a lot of different components. Now, these two data centers, they might be running physical servers, VMware, Hyper-V, doesn't matter to us. We need to install something called the process server, or one or more process servers in our local enterprise, right? This is sort of like the proxy that handles the direct communication with our machines running in our data center, right? It is the extended hand of the orchestration service, and it does what the orchestration service tells it. So those are the two blue servers you see there. And you need one per location, one per high-speed network, one per LAN, if you like. Now, in Azure, we have obviously subscriptions and virtual networks and resources set up there, right? It makes little sense to migrate your entire network into Azure without having established a site-to-site VPN tunnel, right? You could do it, but it's probably counterproductive. So you need to deploy something in Azure, you need storage accounts, affinity group, virtual networks, all those base components that's going to support the servers you're migrating into Azure. What usually happens is that we almost never migrate, for instance, domain controllers. We set up new domain controllers in Azure with the latest operating systems, and we just retire the on-premises domain controllers when there are no services left, right? So you're going to probably set up new resources there. Now, in each virtual network in Azure that you want to migrate something into, you need something called a config server and a master target. Now, the config server, it handles the local orchestration in that subscription or network, and the master target, he's only responsible for copying data. Now, all of this is orchestrated by something in this slide called the RX server, which is this orchestration components that I talked to you about earlier, right? This is the portal, and I'll show you that in a minute. So between the process servers and the master targets, a data channel is established, right? To exchange all the data in your existing servers and all the changes in data that's going to happen as long as the protection or the migration is in place, right? So we'll start off with maybe 500-600 terabytes that needs to be copied into Azure. That process will obviously take some time to do that initial sync. Then we'll do delta sync after that, just keeping things up to date. We'll have dormant copies of our disks lying in Azure, just waiting to be activated. And then once you're ready, you just flip the switch and start those copies instead. So that's the general layout of how it works. Now, let's look at these components in a little more detail. Like the first one is the orchestration portal. Now, a little problem here is that the terminology used in the InMage Scout product, which Microsoft purchased, it's apparent a lot of places. So they might be referring to what we call the MA orchestration portal as the RX service. So I put the old names in brackets on the slides here, so you'll know what I'm talking about. And if you try this out yourself, you'll know what it means. So the MA orchestration portal is a multi-tenant portal hosted in Azure by Microsoft. It is not deployed in your subscription. It has a cloudapp.net address, meaning it's deployed in a cloud service somewhere. And you are granted login access. You get a separate login for this portal, right? To log into it, to actually do things. And it handles all the other pieces, telling them what to do. It does the orchestration, right? Now, no protection traffic, that means data traffic, passes through the RX service at all. That's why we can use it, even though it's provisioned in the United States, right? And you can have several customers and subscription in one. And I'll just quickly show you what my portal looks like. So once you're signed up, you get access to this page, right? Microsoft will send you a username and password and details for logging on to a portal provisioned for you. Now, this is really a very simple setup here. You get an overview of servers you have protected, if they're green or red, and if protection is running, etc., etc. You have your cloud services here. And this is really my primary locations where my existing on-premises resources are running today, right? And yes, you can see I have Amazon support. I can add vCenter. I can add a physical server. They all show up here, right? And I can start migrating from inside one VM container to the other. Now, I might actually be able to migrate from one Azure subscription into another, because it really doesn't care what kind of machine this is, right? So if I were to install my agent into an Azure VM in another data center, I could actually use this to migrate it into Azure, another Azure subscription somewhere else. So it's really up to you. And in this case, I've connected directly to a Hyper-V server, right? I've added one Hyper-V server, and it's enumerated automatically all the VMs on that. If I was only interested in one of them, I could just add this one and pretend that it's a it's a physical server. I'll go add physical server and then point to that one, because all it does is install the agent and starts copying the data. So it's really quite flexible in that sense. Now, the cloud resources obviously are here. And I have in this one 3 separate Azure subscription registered, right? So I can have, there is no limit to how many subscriptions I have here. And as long as I have the requisite components in each of these on-premises data centers and in each of the Azure subscriptions that correlate to them, I can orchestrate all kinds of migrations in here, right? So there is no need for one MA subscription for each customer or each subscription. And the way we get in touch with or authorize ourselves to the Azure service is by management certificate. So the MA portal needs an Azure management certificate, which you easily generates from the Azure management portal. And you register that here, and this service has access to your subscription. And that means that that is also the boundary of delegation here, a subscription, right? We cannot be more fine-grained than that. So this is just to show you quickly what a portal looks like, and I'll come back to this when we try setting up protection later on. I also have some reporting and other various settings here. I can grant users view rights only, so I can have a customer admin come in and see, okay, how are my migrations doing? Whereas I'm the only one who could actually perform the migration. Right, so that's the first piece of the puzzle, the RX server. The next one is something called the configuration server. And this machine has to be an Azure VM because it has to reside inside the subscription or virtual network that you want to migrate into, right? It has to be there in your Azure subscription. There is one of those per subscription, and it does management for that particular set of Azure resources, right? It gets orders from the management portal, and it handles all the things that needs to be performed in that subscription. Setting up new disks that are to be the containers for new data, changing from a dormant disk to an active VM, all that stuff, that's handled by the CS server. And this server also does not receive traffic, right? So I'll quickly show you my CS server, and I'll start out by showing it here in the portal. So I have, these are my 2 servers running in this subscription, the CS and the MT. I'll come back to the MT later on. Now the CS, it also has a portal, right? But this is a specific portal for the resources I'm handling inside this given Azure subscription. So you see, this is a little more detailed, and we haven't had time to change out the logo yet. And you can see this is my selected cloud service name and cloudapp.net, obviously, to indicate that it's running in Azure. Looks similar to what I had on premises, but a lot more detailed, right? Here I get performance metrics for my CS server from the PS servers I have that are attached to this one. And also I can see in detail all the replication relationships between servers I'm currently preparing to migrate or have protection on, right? So I'm hoping you're starting to see, you know, how this can be laid out as one big orchestrating platform, orchestrating communication between different components and different local sites and different Azure subscriptions. So it's only a matter of choosing the right from to when you're orchestrating a migration in here, and I'll show you that later on. So that's the CS server. It also has a lot of reporting, which can be useful if you're troubleshooting or want to figure out how long this is going to take until I can actually migrate. The next component is something called the master target server or servers. Now, this is also an Azure VM, and it has to be an Azure VM because this is the actual receptacle of the data you are migrating into Azure, right? This server takes all the data traffic, all the changes that come in from your data center, and stores it on locally attached drives to this machine in Azure. So you have to have at least one. It has to be an A4 VM, meaning that it can attach up to 16 data disks. Now, if you are migrating a total of more than 15 data disks from your enterprise, right? You have a server. It has 2 virtual physical drives, right? Or at least something that's presented as 2 physical drives. Then you're going to eat up 2 of the disks on this server, right? So you have to figure out how many disks am I protecting in total on my on-premises server, and I have to match up at least the same amount of disks in Azure. And MA is not always very intelligent about warning you about that. So if you protect a server that has 3 disks and the MT that you have only has 2 available, the protection is going to fail. right? So you have to keep track of that on your own. So you're obviously going to need more than one MT server to receive all the replication. And I'll show you what it looks like in a bit. Now, these servers are the ones that actually receive the traffic. They do nothing else but to receive traffic from your protected servers at home. And I can log on to my MT here in Azure. This is the server. It's only running a very tiny component of the Migration Accelerator. What this server really is doing is accepting disks, right? So these two drives here, they are raw partitions. They have no assigned drive letters. I cannot view the contents directly of these drives. I have to like hack myself in. But inside, I would find an exact copy of those two drives on the protected server. This is from a file server running in my local data center, and these are the two disks, the exact same sizes and exact same content copied in here. So that's the role of this server. It provisions new disks, accepts the data, and handles the synchronization as long as that server is under protection. So that's the MT. The last piece, the process server, of course. The process server is installed in your organization where you want to migrate from. AWS, on-premises, whatever, doesn't really matter. But it needs to have local area network connectivity to your servers. It is, although might be technically possible, it's an extremely bad idea to use a remote process server to protect anything, right? Because it's going to receive a huge amount of data from all your protected servers, and you might also need more than one. So this is like our proxy running in your organization. So this is recommended to be a physical server. I'm not really sure why they do that. All my PS servers that I've been using thus far have been virtual, seems to be working fine. But the documentation says this should be a physical server. This server performs caching of changes. It compresses the data, it encrypts it, and then sends it along to the master target server, which it's configured to talk to for this particular server. So to get in touch with this server, obviously the components in Azure needs to talk to this server to tell it what to do. Two ways to do that, either across a regular Azure site-to-site VPN tunnel, or by opening a couple of ports in your external firewall from a public IP into this server. It's up to you. The first one is probably the most used scenario, where you have a network hybrid and you want to migrate some stuff into Azure while some things remain on-premise. The other one might be more usable if you're saying, I'm just going to lift everything into Azure and shut off my local infrastructure. But works either way, it's up to you. So this is the one that's replicating to the master target. Now finally, the last piece is something called the mobility service, or the unified agent, which you need to install on every server you want to protect. And protection, right? I've mentioned this a couple of times. That's the first step. You protect the server, that starts replicating data into Azure. After it's protected and in sync, you can migrate it. So this agent is responsible for monitoring the disks on the server, and it does that by using the volume snapshot service. It monitors every change to the drive, forwards it to the process server, which compresses it and caches it, and then sends it up to the master target. So you will need an agent on all your machines to be able to use this. It has two parts, something called the file replication agent and the volume replication agent. We do not use the file replication agent in migrations into Azure. We only use the volume. Okay, so this is a schematic of the communication we're going to need. Now on top we have the MA service, right, which communicates by HTTP and HTTPS with the configuration server, the CS running in our subscription. It in turn communicates with the master target using the same protocols, and also with the migrated VMs. Where things start to get interesting is here between the on-site process server and the master target. Now this communication is outbound to the CS server. It usually almost works without problem, but this is where we see the problem all the time. So if something is failing here, this process server won't show up when you're trying to configure stuff here. So that's like the #1 troubleshooting thing we do. Something is wrong with this communication, we have to fix it. Either these ports aren't NATed into the server, or something is going on here. That's really the main thing. So two forms of communication between us and the service, and they're all happening between the process server and the CS and MT. Now you notice the connection from the master target is from the master target into the process server, not the other way around. That's why it usually is a source of problem. Okay, so how do we deploy this thing? This is the high-level deployment steps. Now, I would love to show you the complete process, but it just takes too long. It takes a day to put all this into place. Because there is no scriptable install, there are a lot of dependencies and a lot of stuff you have to figure out, so I just can't show it to you in real time. It takes too long. So I've already prepared this, and I'll try to show you the configuration. But you can very easily read the deployment guide. It's pretty straightforward, but there is no desired state template or scriptable install. You all have to do like manual next, configure this IP address and set this thing and whatever, which I'm hoping is going to change. The first thing you do is that you register the subscription you want to migrate stuff into in the MA portal, right? Like I showed you. This is done by a management certificate. You create the necessary resources in the Azure subscription. That is the virtual network, the affinity groups, the storage accounts, and the virtual machines that is going to run the configuration server and the master target servers. You need to install those. Then you install the components, the actual software that is running MA. You deploy the components for the process server in your on-premises network. You install that. You configure the agents. You deploy agents to the servers. This I can show you later on. You configure what I call protection, right, which sets up, okay, this server, we want to protect him with something in Azure. That starts the data copy. And once we're satisfied that this is working as it should and that everything is synchronized, we can migrate the server into Azure, turning off the server at home. That's like the high-level process here. Now, surprisingly enough, I bet these weren't logos you were expecting to see at this conference, right? But there are a lot of third-party components that are required for MA to work. And they are all from the open source world. Now, the reason for this is that the InMage product was really written to handle and run on Linux, right? But it also has capabilities to run on Windows. So it's dependent on Perl. The main flow and functionality of the system is implemented in Perl. And you all know how much fun it can be to run Perl on Windows. Next, it needs Cygwin, which is a Linux wrapper for all the Linux commands running on a Windows platform. It's really an API translator. You need something called the RRD tool, which does logging and graphing for the product, and all the configuration on the CS is stored in a MySQL database. I'll just leave it at that. So how much power do we need for these different things? The CS, that needs to be an A3 standard server. And you're thinking, hey, I only have a small environment. I'm going to try an A2 or an A3 standard, or sorry, basic. That's going to fail, because there are built-in checks that actually sees if the components are the correct size. And you got all sorts of cryptic, strange error messages if these don't fit it. So I'd suggest you just provision this from the get-go. The MT needs to be an A4 standard. Like I said, the reason for this is that it needs to attach a lot of disks for all the targets it's protecting, right? So it needs that number of disks. I did the same thing here. I tried starting out with a smaller VM because an A4 can cost a little to run for an extended period of time. Same problem there. So it needs to have that. And also something called the retention drive, which is sort of like a buffer on the master target. It needs to be a terabyte in size. So the MT, it expects to be able to mount 15 disks, right? The A4 VM has 1 operating system drive, 1 temporary drive, and 16 data drives. One of those data drives is lost because we use that for the retention drive. That leaves us with 15, right? That can protect VMs. And it expects to be able to mount 15 of those. If it can't, it'll fail. So how big should your process server be? The server that is actually communicating in your enterprise with all the workloads and shoveling data into Azure. Well, as with a lot of other things, it depends. how much change do you generate each day? How many megabytes or gigabytes of delta change from your initial volume of data is actually changing per day? Now this table gives some recommendations. I won't go through all of this, but basically less than 300, less than 700, less than a terabyte, you can get off with one server with varying performance characteristics. And if you have more than that, you're probably going to need more than one server. We have 15 minutes left, right? You just gave me 5 minutes. That's not going to work.
4 minutes. No, 15. I'm so sorry.
Okay, 15, right? that could have been really bad. Okay, so we can install our components on Windows Server 2008 or 2012. We can protect anything that's physical, VMware, Hyper-V, or AWS. And we can migrate these operating systems. Windows Server, obviously, and Linux, and Oracle Linux. And this chart is expanding all the time, so we'll probably see parity between the Linux versions supported in Azure also being supported for migration. Yeah, I'll leave you to read that part because I actually want to show you protection right now. So I'll start off by showing you this. This is a file server 1, right? Which is running in my local enterprise. It is currently being protected by MA. It means that it's ready to be migrated when I would like it to. I also have a second server called file server 2, which is this one, which wants to restart, that we are going to set up protection for now. We won't have time to migrate it, but we can set up protection, and so you can see how that starts out. So we'll do that first, right? So I'll go back to my portal here. I have to do this from the main orchestration portal. I go to my cloud services, I select protection. This is the initial setup of data sync between two places, right? And I say, okay, this server is located here. It is this machine. And you can see I have, okay, it's running on Hyper-V. That's what this icon means. It's a Windows server. It does not have the agent installed because this little guy, he is sort of like shaded, and it's not under protection because this shield is gray and not green. So we'll start by setting up protection, right? So the first thing I need to do is install the mobility service, and that happens over here. So it shows me here the server I selected in this pane. Now, if this server needs special credentials to log on to install the agent, I have to enter those here. And I don't exactly remember, so I'm just going to enter those to be sure. No, that's not right. That's the username. And I also select, okay, which CS server are you communicating with? And now these guys are in different Azure subscriptions, right? So it's important I select the right one. And this is the right one because it belongs to the company I told you about earlier. Now, which push server would you like to use? Which server that is residing in the enterprise together with the protection server should deploy the agent? And that's going to be this one, right? You notice the difference in IP address? Everything I have in the 10 address space is running in Azure, and this is my on-premises network. So I want this guy, right? And we're going to install. Now you can see down here the install state is pending, and we can have a look at one of these that is already completed for another server, right? It'll go through this process of installing, and hopefully not long after, this guy is going to light up, and I can configure protection of the server, right? So now that's going to happen. And there is quite a bit of lag in this process, so it really doesn't lend itself well to like on-demand demos like this, because these services, they poll each other every 15 and 30 minutes, and status takes some time to flow up in the system. So this might take a few minutes to turn up here. So I'm just going to leave it at that. Can do a refresh. It's still pending, so I'll just leave it, and hopefully it'll come up. And I'll return to the presentation and tell you about this one while we wait. It's a good idea to create a new cloud service in Azure to house all these components, the MT servers and the configuration server. Create a cloud service dedicated for that purpose. And watch out for limitation regarding storage accounts. There is a very good document on the MSDN websites which tells you how many storage requests and how much data storage accounts in Azure can handle. Just make sure that you don't hit any of those limits, because that will impact both performance and perhaps migration also. The maximum throughput of the standard Azure site-to-site gateway is about 100 megabits. If that is not enough, you can upgrade to the high-performance gateway. You can use ExpressRoute, or you can just say, I'm just going to use my regular internet access because it's faster than 100, right? And you can open the ports into the process server. You really have to figure out what works best for you. Okay, so we have installed the agent, right, on this server. We have protected it, or we have protected another server, which I can show you. When we do that, the process server and the unified agent, they start syncing data. And the first thing we do is something called a resync, which is kind of strange since we haven't synced before, but we're doing a resync anyway. That's the initial transfer of the entire volume into Azure. Once that is finished, we start something called differential sync, where we just sync changes, right? And we'll have a look at a server which has reached differential sync status. So I can't see that in here. This portal doesn't give me enough detail. But if I visit the CS server that is actually performing or has controlled this migration, I can see that status. And this is the server I'm talking about, file server 1, right? And you see I am in, it's active, the heartbeat is okay, and a common consistent point is available. That means that the latency or the change rate between Azure and this server is so small that we're able to fail this server over if we so choose. So everything is looking good here. I can have a look at the plan details. And you see here, I have from the C drive, I have a mount point into this strange folder. And from the D drive, I have into this folder. Now, if we quickly have a look at the master target server, we will recognize those paths because they are here. These are junctions or mount points in the file system for those disks that we couldn't see, right? So that's the way it handles connection between mounted disk. Everything is mounted under this folder on the C drive, but it really points to another drive somewhere else, right? So this is some internal magic going on right here. But that's why you're seeing those paths displayed here. Now I can see, is resync in progress? No, it's not. What is our status? We're in differential sync. Is resync required? No. Resync has been completed. And we're now just syncing changes, right? And also I can see down here on this graph how much data has changed at any given point. How many megabytes per minute or hour has actually changed for this server. Now obviously this is a demo environment. I am the only one using it, so not a lot going on. Right? And this is where you will see if your process server is too small for the task, right? If you never reach differential sync, or you only maybe reach differential sync at night, you know that, okay, this server is not powerful enough to handle all the changes. I need a bigger server or several servers. A lot of details in here that you can have a look at. So this server is green and potentially ready for migration. And I think we're going to go all in here and see if we can migrate this server. I'm just going to have a look and see if the agent was able to install. Yes, that's fine. It's still pending, right? So, and like I said, this is the problem. Things happen a little slowly. But fortunately for us, we already have this other server here. So now we can visit the migration page. Perhaps. And these are my protected applications, right? And you remembered I said that it can detect all the servers making up a group of servers providing a service or an application. This is what we're displaying here. Now this group only has one server, so it's okay, you know. It's not doesn't have any dependencies. But I can now select to hopefully, if this one will refresh, I can migrate this server into Azure. It probably won't finish until we run out of time, but what's going to happen is that it'll do some checks. It'll have a look at the existing machine, the way it looks in my data center, number of CPUs, memory, etc., and it'll suggest a compatible machine size in Azure, right? And it says, I suggest you run this as an A4. And if I say OK, it's going to detach the disks that belong to that machine from the master target server, make them available as regular disks in Azure storage, and then create a new VM for me and attach those disks to it. Now, we'll see if we can figure that out. So this server, Windows, this is the IP address, we're going to migrate that. Hopefully. I swear it worked a moment ago. Let's try that again. Okay, migration. You see, something is wrong with the internet. I blame the internet for this. Do we have internet? Yes, we do. All right, let's try this. Complete refresh. When all else fails, have you tried turning it on and off again? Oh, man. Come on, internet. Okay. So if it had worked, that what was going to happen, right? You probably won't believe me, but this is the first time this has happened to Migration Accelerator. Okay, we're back. Maybe. Thumbs crossed. Fingers crossed. Migrate. Come on. Yes, thank you. So this is the source server, right? And how would you like to migrate? A recovery point, latest time, latest tag. We always choose latest time because that's the most up-to-date sync. So this is the server we're going to be working with. We get information here about what its current configuration is and which migration server. The first thing I need to do is select which cloud service to place it into in Azure, right? This is a requirement of the Azure platform. Every virtual machine, every compute resource needs to reside inside of a cloud service. So I'm just going to select this one. You probably have this planned out in advance, right? Which cloud services are for which servers. Next is which network, right? Which virtual network are we going to virtually patch this server into? I select that one. I only have one here. Now, obviously, this is also the reason why we have separate CS servers, because they reside in a virtual network and they only see that network. Which subnet would you like? I would like it in this subnet. And if I click here, I get to change some of the details settings. I can choose a larger VM. I can go for medium. I can select the migration order. This is not relevant here because there's only one server, but if there were 10, I could select in which order this one was to be started up. And I can also add additional endpoints if this was a web server or stuff like that. So we'll save that. Right. And we'll press activate. Now, this is going to take some time, and we won't probably see the end of it because we're almost out of time, but now it's going to detach those disks from the MTU, automatically provision a new VM for me, and attach those disks and start the service. Now, the old server is still running, right? So this is a good time to turn that off. There is no automation in MA to actually stop services or turn off servers in your existing enterprise, so you have to manually handle that. Okay? So we'll just do this last slide here before I say goodbye. Because there are a couple of things that you might need to be aware of, right? If you have something else that's using VSS on your server, that's probably going to come into conflict with the Migration Accelerator because it's using VSS as well. So that's something we have to figure out. Always use case sensitivity when you're addressing your virtual network names in Azure. This is a general requirement, but it's painfully obvious in MA because it has to understand the case of your virtual network names. Watch out for those restrictions I told you. I have actually migrated a Generation 2 Hyper-V server, Hyper-V guest into Azure using this product, and it wouldn't start. And the reason was that it was a Gen 2 VM trying to boot from a SCSI drive. I downloaded the disk, it worked perfectly, but I just figured out, hey, this is a Gen 2 machine and I can't start it up here. If you have local servers that are using the D drive, and I guess all of us have, the D drive is reserved for something else on an Azure VM called temporary storage. So you will need to fix your drive assignments. And if you were to change the public IP of your CS server, you have to change the configuration on several product components in MA afterwards. Just be aware, because that's the main guy. He's being referenced by IP, by all the other moving parts, so you have to change that. Okay, the next version, I have some wishes here. Would be great if we could script the install and log on with our Azure AD accounts instead. Hopefully that's coming in later versions. I also included these, and you'll get the presentation so you can have a look at where you can find out more about MA. I won't have time for questions. You have my email, and like I said, the presentation will be given to you, so you can just contact me if there are any questions. Please evaluate the session. If you did not like it, give me a green one. If you think it was okay, another green one, or if you liked it, give me a green card. Thank you very much for coming, and have a nice weekend.